Welcome to Real-Time Signals Technologies. Today I am going to give a brief idea about continuous integration and continuous deployment. So let us start with an introduction to CICD. A well-defined software development lifecycle practice in a typical organization generally has projects running with users and roles. These users design, develop, test, and deploy the jobs as per the business need or requirement. But have you ever wondered, what happens to the code after that? What if multiple developers want to work on the same job? How would you store this code, and how does one ensure that other developers always pick the right version? Well, welcome to the world of continuous integration. Quote, in this video, I will be highlighting the process of continuous integration, the importance of being continuous, and how to achieve that using Talon C Builder with Jenkins and Maven plugins. The process for builds and deployments using a distributed version control system like Git and continuous integration, continuous delivery could be 1. The developer creates a new temporary branch out of the master branch and switches checkout into the new temporary branch. This new branch should be used for one change only with the intent of using the new branch for no longer than a few hours. 2. The developer implements the change in the new branch. 3. The developer runs a build process in the development environments with execution of the unit tests and the integration and automated acceptance tests from behavior-driven development (BDD) that can run in the development environments. There can be one or multiple development environments, depending on the requirements and complexity of the project. 4. The developer commits the change to save the new branch locally. 5. The developer publishes the new branch to upload the new branch in the master repository. 6. The developer sends a pull request to a senior-led developer. 7. The senior-led developer does a code review of the change. 8. If the senior-led developer is satisfied with the change, then the senior-led developer merges the new branch into the main branch and triggers a build and deployment process into the pre-production or production environment for continuous delivery. However, although the basics of this process will remain the same, most environments require a more sophisticated branching strategy. Jenkins, SonarQube, and Jacoco are excellent tools for deploying applications. Using Jenkins to build your application, running tests with Jacoco code coverage, making SonarQube analysis, and saving all results to SonarQube online is a great way of deploying your applications. You will be able to use Jenkins with Maven and manage following tasks: build application, running tests with Jacoco test coverage report, running SonarQube analysis, pushing test result, test coverage report, and SonarQube analysis report to SonarQube server. Jenkins is an award-winning, cross-platform, continuous integration and continuous delivery application. Use Jenkins to build and test your software projects continuously, making it easier for developers to integrate changes to the project, and making it easier for users to obtain a fresh build. It also allows you to continuously deliver your software by providing powerful ways to define your build pipelines and integrating with a large number of testing and deployment technologies. SonarQube is an open platform to manage code quality. As such, it covers the 7 axes: duplicated code, coding standards, unit tests, complex code, potential bugs, comments, design, and architecture. We use the Jacoco Maven plugin for 2 purposes. It provides us an access to the Jacoco runtime agent, which records execution coverage data. It creates code coverage reports from the execution data recorded by the Jacoco runtime agent. For the installation of, you can refer the slide 3 and SILDE 4. Continuous delivery is a DevOps software development practice where code changes are automatically built, tested, and prepared for a release to production. It expands upon continuous integration by deploying all code changes to a testing environment and/or a production environment after the build stage. It is often assumed that if we want to deploy software more frequently, we must accept lower levels of stability and reliability in our systems. In fact, peer-reviewed research shows that this is not the case. High-performance teams consistently deliver services faster and more reliably than their low-performing competition. This is true even in highly regulated domains such as financial services and government. This capability provides an incredible competitive advantage for organizations that are willing to invest the effort to pursue it. The practices at the heart of continuous delivery help us achieve several important benefits. Low-risk releases. The primary goal of continuous delivery is to make software deployments painless, low-risk events that can be performed at any time, on demand. By applying patterns such as blue-green deployments, it is relatively straightforward to achieve zero downtime deployments that are undetectable to users, faster time to market. It's not uncommon for the integration and test, fix phase of the traditional phase software delivery life cycle to consume weeks or even months. When teams work together to automate the build and deployment, environment provisioning, and regression testing processes, developers can incorporate integration and regression testing into their daily work and completely remove these phases. We also avoid the large amounts of rework that plagued the phased approach. Higher quality. When developers have automated tools that discover regressions within minutes, teams are free to focus their effort on user research and higher-level testing activities such as exploratory testing, usability testing, and performance and security testing. By building a deployment pipeline, these activities can be performed continuously throughout the delivery process, ensuring quality is built into products and services from the beginning. Lower costs. Any successful software product or service will evolve significantly over the course of its lifetime. By investing in build, test, deployment, and environment automation, we substantially reduce the cost of making and delivering incremental changes to software by eliminating many of the fixed costs associated with the release process. Better products. Continuous delivery makes it economic to work in small batches. This means we can get feedback from users throughout the delivery lifecycle based on working software. Techniques such as A/B testing enable us to take a hypothesis-driven approach to product development, whereby we can test ideas with users before building out whole features. This means we can avoid the two-thirds of features we build that deliver zero or negative value to our businesses. Happier teams. Peer-reviewed research has shown continuous delivery makes releases less painful and reduces team burnout. Furthermore, when we release more frequently, software delivery teams can engage more actively with users, learn which ideas work and which don't, and see firsthand the outcome. It seems that in the world of DevOps, development teams are continuously doing something. They use continuous integration, continuous delivery, and continuous deployment in order to deliver software more quickly than ever. But what do these terms really mean? They're obviously different, or else we wouldn't need different phrases to describe them. So what are the differences? Continuous integration (C) is a process that packages code written by developers on a regular basis. When a developer commits a piece of code to a code repository, C takes over. C servers specialize in gathering the pieces of code necessary to create the final executable piece of software. C servers run unit and integration tests to ensure no defects are introduced. C stores finished packages in a repository. Typically, several more steps are required before the code is elevated to production. Often, the code is moved to testing environments for manual testing or performance testing. Continuous integration is a prerequisite to continuous delivery. Continuous integration creates the package, but there are usually more steps before it can be released to production. Taking the next step into continuous delivery means that code is always ready to go to production. But first, someone has to take action. Usually, a product owner will approve the code before it goes live. Continuous deployment allows code to be pushed straight to production after the developers commit it. There is no approval process or sign-off. This is how companies like Netflix deliver code thousands of times per day. Artifactory is a product by JFrog that serves as a binary repository manager. Like Artifactory, Bintray is package agnostic and works seamlessly with all the different package clients, so it can be fully integrated into any continuous integration, continuous delivery ecosystem. Artifactory is a universal repository. Before installing Artifactory, set up the Docker Community Edition using the following commands on your machine. Using following commands: sudo yum install yum utils, sudo yum config manager, add repo, https://download.docker.com/linux/centos/docker-c.repo. Now install the latest Docker CE and start using the commands sudo yum y install Docker CE, m2 start sudo systemctl start docker. Part of the reason why running Artifactory as a Docker container is convenient is that pre-built images for it already exist. The images come with the Nginx web server and Docker repositories built in. The Artifactory container images are available from Bintray. You can pull them with a simple docker pull command, like so: docker pull docker.bintray.io, JFrog, Artifactory OS, latest. This would pull the image for the latest version of the open source edition of Artifactory. If you want a different version, you can specify that in the command. Images are also available for the Pro registry and Pro versions of Artifactory. This integration allows your build jobs to deploy artifacts and resolve dependencies to and from Artifactory, and then have them linked to the build job that created them. To set up Jenkins to collect Docker build info, carefully execute the following steps. 1. Install Docker on all Jenkins build agents. 2. Set up Artifactory as a Docker registry. 3. Ensure Docker is working correctly with Artifactory. 4. Make sure Artifactory reverse proxy is trusted by Jenkins. 5. Make sure you have the correct version of the Jenkins Artifactory plugin. 6. For OS X agents, run a socat container. 7. Test your setup. Install Artifactory plugin using the link https://wiki.jenkins-c.org. Display Jenkins Artifactory Plus plugin. The following are some of the basic activities you will carry out, some of which are best practices for Jenkins server maintenance. URL options. The following commands, when appended to the Jenkins instance URL, will carry out the relevant actions on the Jenkins instance. http://localhost port 8080/jenkins/exit-shutdown Jenkins. http://localhost port 8080/jenkins/restart-restart Jenkins. http://localhost port 8080/jenkins/reload- to reload the configuration. Backup Jenkins Home. The Jenkins home directory is nothing but the location on your drive where Jenkins stores all information for the jobs, builds, etc. The location of your home directory can be seen when you click on Manage Jenkins Configure System. Set up Jenkins on the partition that has the most free disk space, since Jenkins would be taking source code for the various jobs defined and doing continuous builds. Always ensure that Jenkins is set up on a drive that has enough hard disk space. If your hard disk runs out of space, then all builds on the Jenkins instance will start failing. Another best practice is to write cron jobs or maintenance tasks that can carry out cleanup operations to avoid the disk where Jenkins is set up from becoming full. Continuous integration, with automated test execution and trends, has changed the way companies look at build management, release management, deployment automation, and test orchestration. This section describes Jenkins' best practices in order to provide executives, business managers, software developers, and architects a better sense of what Jenkins can contribute throughout the project lifecycle. 1. Always secure Jenkins. This best practice is around authenticating users and enforcing access control on a Jenkins instance in the default configuration. Jenkins does not perform any security checks. This means any person accessing the website can execute arbitrary code on the Jenkins master and all connected agents, including extracting all your passwords, certificates, and other private data. Besides, just configure Jenkins and jobs, and perform builds. This configuration is only acceptable for use in very small intranets and test setups. 2. In larger systems, don't build on the master. If you have a more complex security setup that allows some users to only configure jobs but not administer Jenkins, you need to prevent them from running builds on the master node. Otherwise, they have unrestricted access into the Jenkins_home directory. You can do this by setting the executor count to 0. Instead, make sure all jobs run on agents. This ensures that the Jenkins master can scale to support many more jobs. And it also protects builds from modifying potentially sensitive data on $Jenkins_home accidentally, maliciously. If you need some jobs to run on the master, e.g. backups of Jenkins itself, use the Job Restrictions plugin to limit which jobs can be executed there. 3. Backup Jenkins home regularly between archive builds. Build logs that let you determine exactly what happened, and the SCM history information that tells you exactly what was built. Jenkins contains a lot of information you don't want to lose. 4. Integrate tightly with your issue tracking system, like Jira or Bugzilla. To reduce the need for maintaining a change log, the integration helps to track changes as they are made, including build status, what build has been performed for this requirement or defects, and the link to the actual build results and artifacts. 5. Set up Jenkins on the partition that has the most free disk space. Jenkins needs some disk space to perform build and keep archives. All the settings, build logs, artifact archives are stored under the Jenkins_home directory. Simply archive this directory to make a backup. Similarly, restoring the data is just replacing the contents of the Jenkins_home directory from a backup. 6. Archive unused jobs before removing them. All unused jobs should be archived so they can be resurrected if the need arises. See Administering Jenkins for ways to do this. 7. Avoid scheduling all jobs to start at the same time. Try to avoid scheduling all jobs to start at the same. Jenkins' competitive advantage is that its plugins number upwards of over 1,400. These plugins support the automation of various development tasks and were primarily developed to quench the need for CICD in Java code environments. The development tasks that all these plugins support include but are not limited to running tests, static code analysis, building projects, and deployment, among many other capabilities. A parameterized plugin. This plugin lets you trigger new builds when your build has completed, with various ways of specifying parameters for the new build. You can add multiple configurations. Each has a list of projects to trigger, a condition for when to trigger them, based on the result of the current build, and a parameters section. A pre-SCM builds tip plugin. This plugin allows build step to run before SCM checkout so that you perform any build step action on the workspace, cleanup, add a file with some settings for the SCM, etc., or call other scripts that need to be run before checking out from the SCM. A job configuration history plugin. This plugin saves a copy of the configuration file of a job config XML for every change made in of the system configuration. You can also see what changes have been made by which user if you configured a security policy. A build failure analyzer. This plugin analyzes the causes of failed builds and presents the causes on the build page. It does this by using a knowledge base of build failure causes that is built up from scratch. Saving statistics about failure causes is also possible. A nested view plugin. This plugin adds a new view type that can be selected when adding job views. This view does not show any jobs, but rather contains another set of views. By default, clicking on the View tab for a nested view shows a list of the subviews it contains, with folder icons. You can also configure a default subview to bypass this intermediate page and jump directly to that default view. What is Jenkins Pipeline? Jenkins Pipeline, or simply Pipeline with a capital P, is a suite of plugins which supports implementing and integrating continuous delivery pipelines into Jenkins. A continuous delivery (CD) pipeline is an automated expression of your process for getting software from version control right through to your users and customers. Every change to your software, committed in source control, goes through a complex process on its way to being released. This process involves building the software in a reliable and repeatable manner, as well as progressing the built software, called a build, through multiple stages of testing and deployment. Creating a Jenkins file and committing it to source control provides a number of immediate benefits. Automatically creates a pipeline build process for all branches and pull requests. Code review, iteration on the pipeline, along with the remaining source code, audit trail for the pipeline. Single source of truth 3 for the pipeline, which can be viewed and edited by multiple members of the project. While the syntax for defining a pipeline, either in the web UI or with a Jenkins file, is the same, it is generally considered best practice to define the pipeline in a Jenkins file and check that into source control. Why pipeline? Jenkins is, fundamentally, an automation engine which supports a number of automation patterns. Pipeline adds a powerful set of automation tools onto Jenkins, supporting use cases that span from simple continuous integration to comprehensive CD pipelines. By modeling a series of related tasks, users can take advantage of the many features of pipeline. Code pipelines are implemented in code and typically checked into source control, giving teams the ability to edit, review, and iterate upon their delivery pipeline. Durable pipelines can survive both planned and unplanned restarts of the Jenkins master. Pausable pipelines can optionally stop and wait for human input or approval before continuing the pipeline run. Versatile pipelines support complex real-world CD requirements, including the ability to fork, join, loop, and perform work in parallel. Extensible, the pipeline plugin supports custom extensions to its DSL and multiple options for integration with other plugins. While Jenkins has always allowed rudimentary forms of chaining freestyle jobs together to perform sequential tasks, Pipeline makes this concept a first-class citizen in Jenkins. Declarative pipeline fundamentals. In declarative pipeline, Agile teams are self-organizing, with skill sets that span across the team. This is accomplished, in part, with code review. Code review helps developers learn the code base, as well as help them learn new technologies and techniques that grow their skill sets. So, what exactly is a code review? When a developer is finished working on an issue, another developer looks over the code and considers questions like, are there any obvious logic errors in the code? Looking at the requirements. Are all cases fully implemented? Are the new automated tests sufficient for the new code? Do existing automated tests need to be rewritten to account for changes in the code? Does the new code conform to existing style guidelines? Code reviews should integrate with a team's existing process. For example, if a team is using task branching workflows, initiate a code review after all the code has been written and automated tests have been run and passed, but before the code is merged upstream. This ensures the code reviewer's time is spent checking for things machines miss, and prevents poor coding decisions from polluting the main line of development. What's in it for an Agile team? Every team can benefit from code reviews regardless of development methodology. Agile teams, however, can realize huge benefits because work is decentralized across the team. No one is the only person who knows a specific part of the code base. Simply put, code reviews help facilitate knowledge sharing across the code base and across the team. The general process for using Review Board for pre-commit review is as follows. Make a change to your local source tree. Create a review request for your new change. Publish the review request and wait for your reviewers to see it. Wait for feedback from the reviewers. If reviewers have requested change, defect tracking spans across various levels of software testing. A defect may be captured during design, development, or testing phase. Each phase can be backtracked to a previous one in order to map the defect to its appropriate root cause. Defect tracking mechanism is a very crucial aspect of a software development process which must be dealt with great deal of accuracy. The implications of defects hidden within the system may prove to be a peril, if not handled with the right acumen. When the software testing life cycle is planned, the details regarding uncovered defects must be clearly documented by the test team. A proper defect tracking system shall aid the developers in their defect correction activities. Defects must therefore be prioritized so that high-priority defects are dealt with first, gradually moving on to the lower-priority defects. Eventually, as the team keeps solving the issues, defects, the solutions are integrated into a new software build, which instigates retesting. The testers record such proceedings into the defect tracking tool. The fixed defect status report must include the description of the fixed as well as other affected areas of the system. The following points describe the ways to carry out defect tracking. Precisely, these can be described as the steps or process of defect tracking. Analysis. In analyzing an application, a tester needs to be a keen observer and should also possess a great deal of knowledge in this regard. A tester is expected to apply diagnostic observation to be able to uncover the test scenarios from both a positive as well as negative approach. Defect entry. If it occurs to the tester that an unexpected system behavior has occurred which turns out to be a defect, it should be entered into the defect tracking tool by the tester. Recurrence. How shall a recurring defect be tracked as or handled should be analyzed. Whether the defect needs to be marked as a new defect or the previous defect be reopened. Closure. Ideally, the test manager should close the defect after all the relevant issues have been resolved. List of popular defect tracking tools. Bugzilla is an open-source web-based bug tracking tool developed by Mozilla. It is one of the leading bug tracking tools used by many organizations. Jira, developed by Atlassian. According to Atlassian, Jira is used for issue tracking and project management by over 50,000 customers. Companies like Twitter, NASA, Audi, The Telegraph, and much more are using Jira software. Why still thinking? Give it a try. It is a commercial tool and it provides a free trial. Mantis. MantisBT is an open-source web-based issue tracking tool. It also provides a mobile version. Users are able to get started in minutes to manage their projects. Compatible with Chrome, Firefox, Safari, Opera, and IE7+. It has features like email notifications, chat, mobile version, etc. HPOM. HPOM is an application management solution to help you to define, build, test, and deliver applications fast and with confidence across the entire software development lifecycle (SDLC). It's a premium tool and has a free trial.